Back at the workbench with the mini-bot. Welcome to Hack a Week. I've got some code uploaded to the mini-bot. We'll go over that in just a minute, but once I did that, I figured out that this little battery holder, the little 3-volt coin cell one, just not enough amp hours available in there. It ran for, well, one of them, for starters, one of them didn't make it go. I put 2 of them on it, one for the microcontroller, one for the motor power. That lasted about a minute, and then it started to stall and not work right. So that didn't work out, but what did work out was putting a 9-volt battery on board, and I just mounted a little switch. There's the switch that I put on the 9-volt battery connector. That did the trick. 9-volt battery works good for it. It runs it just fine. So let's get to the code and how to upload it. Here we are on the Pololu Robotics and Electronics page for the A*32U4 Micro. There's a description here, there's some tabs down here. We're in the description area. Let's go to the resources. That's right there. And in the resources, there's a user's guide that'll help you out a lot. First place we need to go is to the Pololu A* software and drivers. That's a zip file. So we'll go ahead and unzip it. And I've already unzipped it to a folder. I'll go ahead and get to that folder right now. So here we are in my files, the A* 1.4.0, and we'll click open that. And over here there are a few files. Let's go ahead and zoom in on those so you can get a better look at just what I'm clicking on here. Move that into view. There's an add-on, the bootloaders, the drivers, the libraries, etc. So what we're after first is the drivers. You go in there and there's the drivers for the A*. The way that you load those is you will plug in the microcontroller. Windows will prompt you for a driver, and then you direct it to that driver folder and allow it to load up the drivers. And now here's the add-on for the whole thing. That whole folder right there, that Pololu folder, we're going to drag and drop that into the Arduino folder. So in this folder, in the A* 1.4.0 folder, there's the add-on for this microcontroller, and we need to put that in the hardware folder. So over here on the desktop is the Arduino 0022 folder. Let's open that, and we'll drag that over here. Let's click that. There's hardware right there. I've already done a drag and drop, and you can see here's the add-on, and there's the Pololu folder, and I have dragged it over here to the hardware folder in the Arduino folder. It needs to be in there. Once it's in there, then this board will show up on the board selection in the Arduino Ide. Let's check that out. And the next thing we're going to do is go to the Arduino software, which is down here on the Pololu page. You're going to go there, you're going to download the Arduino Ide. Alright, here I am on the desktop. I have installed the Arduino Ide, so we're going to open that. It'll take a second to open a window, and it'll open up with just a basic blank sketch area. And in this area is where you put your code. Right here it's got a pretty self-explanatory section. I will post the code for this robot on the Hack a Week page. You can just pretty much copy paste it right into this whole area on the Arduino sketch environment. So let's go ahead and open up what I have called the mini-bot basic drive. I'm going to go ahead and make this window a little bigger. Okay, here's the IDE, and here's the code that I wrote. You can make comments in the code, and the compiler will ignore them, and the way you put a comment in there and get it to ignore it is you put a / and an asterisk, write whatever you want as a comment, then you write an asterisk and a /. The first thing we need to do is make our declarations of what the pins are going to do. So you put int right there. That's a command that means integer. And so right here we have the motor for the right side of the robot. I named it MR, and there are two leads to that motor, 1 and 2. MR1 equals 6. That's pin 6. And then there's a semicolon, a space, 2 forward slashes, and you can write some commenting there if you put 2 forward slashes after it. So we do that for the right motor and the left motor. Now down here is where the code actually goes that gives you your setup, what mode those pins are going to be in. So all of those pins are outputs, and so I put in here pin mode MR1 output. You can find out a lot more about all this stuff by getting into the Arduino website. There's tons and tons of tutorials there how to code. This part of the code is the loop section. It starts out with void loop, and then there is a bracket, the curly brackets. There's a curly bracket going that way and a curly bracket going back the other way, and that's where you put your loop in between those curly brackets. There's tons of tutorials, like I said, on the Arduino page, so you can go there for more info on what all this stuff really means and how to do your programming. But anyway, I'm going to explain what goes on in this loop. It's what's going to make our motors drive. This code will make the motors drive forward for 1 second at 25% speed, then they'll stop for 1 second, then it'll go backwards for 1 second, stop for 1 second, and repeat the whole loop. This is an analog write command, and we're going to make that analog write happen on the pin for MR1 and MR2 and ML1 and ML2. That's the right motor, 2 leads, the left motor, 2 leads. To go forward, we're going to make the pin at MR1 have a value of 50 as its output for the pulse width modulation. You can put a value between 0 and 255 on pulse width modulated pin outputs. On 2, we're going to call it 0. So it's just basically going to be nothing at that pin, and 50 at this pin. That's going to make it drive forwards. Same thing over here on the left motor, 50 and 0. Now we're going to do that for 1 second. Then we need to turn those motors off. So we write the same thing again, but we give everything a value of 0. Then we delay for a second. Now we go down here to where it's reversed, and we just basically flip those values around on the pins. Pin 1 or MR1 now is 0, MR2 is 50. That's going to make the motor spin backwards. Same thing for the left motor. And then we stop the motors again, and there's a 1 second delay. So this is our first basic program that we've uploaded. Let me show you how that upload works now. So once you have the driver installed and you have the add-on installed in the Arduino hardware folder, in the Arduino folder, you will then go here to Tools, and you go down here and you'll select the board. It'll be all the way down here at the bottom, the Pololu A-Star 32U4. Then we're going to select the port, but right now we're going to plug it in. So right here's the bot, here's my cord. I'm going to plug this in right now. You'll hear the bonk that Windows does when you plug in a USB device. And now that it's plugged in, we go to Tools, and we go down here to the port. We're going to select COM6. Now if you unplug the microcontroller and plug it back in again, you'll have to go select that port one more time. Right here we have a button that will do the upload for us. I believe it's also, let's see, it's up here in one, yeah, it's in the sketch menu is upload. You can also hit Control U. But anyway, we'll go ahead and upload this. You can see that it's uploading. You hear the bonk. And it's done uploading. And that's it. Now, I want to do this one more time. So let me see, I'm going to go to the port, select COM6. Now I want you to see what happens on here on the board when I click upload. You watch, you'll see some lights come on. See that little light that came on? And then you'll see a flickering light, and that means that the code is uploading. Now it's all uploaded. So let's put this on the bench and see what our code does when we turn on the switch. There's the little bot sitting on the bench. Let's go ahead and turn it on, see what our code does. And it just drives forwards and backwards. The little squealy noise you hear is the LED at the back. The little tail dragging LED likes to squeak in the forward mode. Kind of sounds like it's doing a burnout. You see it has a bias to turn a little bit toward the right. We can fix that. I've run into that before. Sometimes the code needs to be altered just a little bit. The motors may not be perfect the way that they pulse width modulate. So we can actually change those values on one of the motors, and it wants to turn a little bit to the right. So let's see, if we're looking at it like this and it wants to turn to the right, that means that this motor is spinning maybe a little bit fast. If I'm turning towards the right, that means that the left motor is running a bit fast. So I need to leave the right motor at 50, and it's the left motor, that's the one that I want to put at 45. Let's try that. One more time. Let's see how we operate now if we've lost that bias to turn to the right. It's a little better. It tends to take off a little bit towards the left and then straighten itself out. That battery on the back is biasing things a little bit too. Okay. Now what? Well, let's give it a little bit longer time to drive, and we will put it on the floor and see what it does. So if I want it to drive longer, I go right here to that delay. Here's the commands that make the motor go, and that delay of 1000, that's 1000 milliseconds, and that equals 1 second. Let's change that to 2 seconds, and let's take the delay that's between the time that it moves forwards and backwards, and we'll change that to a half a second. That would be 500 milliseconds. And in the reverse, let's leave the reverse at 1 second, and we'll change the delay to a half a second. Let's upload that, and we'll put it down on the floor of the shop here and see how it scoots around. Okay, much more room to scoot around now. Let's turn it on, see what it does. Well, you know what? That little LED thingy does not like dragging across concrete. Let's fix that. Slight modification to the rear end. I dug this out of a drawer of junk hardware. It's just a little, came out of a printer, I think. It's just some kind of a little guide roller with some spring steel on it, and I glued it right to the perf board with some super glue, the kind that hobbyists use, that has the two-part thing. You know, you put the super glue on, then you hit it with the kicker, and it goes off. Let's try that. Much smoother. And it looks like we got our bias to turn to the right straightened out. And of course it's going 2 seconds forward, 1 back, so it's going to keep working its way forward. Okay, so let's move along to another function. What if we want our robot to turn? So back here on our code, let's see. We've got our forward taken care of, and let's go to the reverse. Let's go ahead and take the left motor, and we'll set that at 0 on both leads, and that means that the right motor will be running only So if only the right motor is running, let's see, that's going to make the bot spin around in a clockwise fashion as it goes backwards. So we'll see just how many degrees it rotates around, and then we can change the delay number, and that will get us to the turning point that we want as it does its backup thing. And then of course when it goes forwards again, it will be turned around and go in the other direction. So what we're shooting for is a 180 degree turn. So let's see if 1 second of operation with only one motor will turn it around 180 degrees. Okay, code is uploaded. Let's go forwards. How come I have both motors running? Or are they? No, they're not. So I see what's happening here. That one motor and that new tail dragger thing that I put on isn't letting it spin around as easily as it did when it had the LED and it was on the wood of the bench. But there is an alternative. Alright, back to the code. Let's see, here's the section that does the reverse. What we did was we took that left motor and we set it at 0, and we've got the right motor running backwards, so that means that MR2 is at 50. Well, what if we take the left motor and we spin it forwards at 50? So let's take this value, change it to 50, and what that should do now is make the motors spin in opposite directions, and it will do a little bit more of a tank turn. Let's upload that and see what we've got. And here we go, shooting for a tank turn. Not quite. It's having a hard time with that little rear tail dragger. There it went that time. Okay, let's try maybe another tail on there. I put a LED back on there underneath, and I also moved the battery to a place where the weight is a little better distributed up by the motors too, which gives them better traction. I put a 1 second delay in too at the beginning of the code, so that when I flip the switch, I've got time to get my hand away before it starts driving off. So let's see what happens now. Wow, so the tank steering is really working, and it's spinning it around 180 degrees basically twice, you know, so yeah, that's kind of funny. It's going the other direction. Yep, it's like 1.5 turns. So 1.5, yeah. So, how about that? So if I wanted to just spin around 180, if it's going 1.5, theoretically I should be able to take that delay number and divide it by 3, and then take the result. Let's turn it off, and we'll try changing the code to that. Okay, let's see here. We've got there's our spin around code right there, and there's the delay, and it's at 1000 right now, and it does pretty much a turn and a half. So let's change that to 333, which is basically a third of 1000. Forget about the 3 repeating stuff. Tools, and let's go there and change COM6 and upload. We'll let that upload and put it on the floor and see what we get with that. Okay, turnaround time changed to 333 milliseconds rather than 1 second. Let's see what we have now. How about that? Exactly a 180 degree turn. See this stuff, programming and all that, it's all about numbers and delay times and things like that, and it's really not too hard. So there's a good basic start for you on the Arduino code for the mini-bot. Next time we'll get the sensor hooked up and we'll have that working. But for right now, we've got a bot that just drives forwards for 2 seconds, turns around, and drives the other way for 2 seconds. And you now know how to do that. Anyway, thanks for watching. Thanks for all the donations. And until next time.